Alright, welcome to JAMB. Like today we are going to be looking at how to solve stoichiometry question. We are going to be focusing on calculations. Okay, so now the only thing you need to do now is stay tuned, watch the video to the end, get your writing materials, your pen, your book, and finally your calculator, because you are going to be needing it in this video. Okay, so now let's go. Now I always say this, the basic thing in stoichiometry is number of moles. N is a symbol, it denotes number of moles. Now number of moles is what connects every formula you are seeing here. Now the first formula is mass over molar mass. We give you a number of moles. Concentration, also known as molar concentration, also can be called molarity. Molarity, take note. Multiplied by volume in dm cube will give us number of moles. This one is just there, just to balance up the table. Okay, now we can rewrite this formula. You know why it's true? Because in the equation you can be given volume in cm cube. What will you do? The formula will now be concentration or molarity multiplied by volume in cm cube over 1000. Okay, so now the next formula is volume over molar volume. Molar volume is a volume at standard temperature and pressure. Do you understand? Now molar volume is a constant. Is a constant. Now the value, every constant has a value. So therefore the constant is 22.4 dm cube. Let me write it out. I said 22.4 dm cube. Now we can only use this value when our volume given in the equation is in dm cube. Take note. Now when our volume in the equation is given in cm cube, you cannot use this value. Rather, you will convert this value to cm cube. So if you convert this value to cm cube, you will multiply by 1000 to give you the value in cm cube. Now if you multiply by 1000, you will get a value which is 22,400 cm cube. Now this is the value you use when the volume in the equation is given in cm cube. Do you understand? Now the next thing we have to look at is the next formula. The next formula, these are just symbols. Okay, the first one P signifies pressure. The second one volume signifies V signifies volume. Okay, now T is temperature. Now this one is the odd guy. R. It's called molar gas constant. Now the molar gas constant can also be called ideal gas constant. Now as I said earlier, every constant has a value. Now let me wipe this out. Okay, so now the value for the value for our molar gas constant is 0.08205. Now it doesn't just have one value, like the way this molar volume has two values when the volume is given in cm cube and when the volume is given in dm cube. It's also the same for the molar gas constant. It has a second value, which is 8.314. This is the second value. Take note of it. Don't ever forget this value. Now, when and when should we use these values? Now, this value can be used when your volume is number 1 in dm cube. Don't forget, your volume is in dm cube. Now, your pressure is in atmosphere. In short, called ATM. Don't forget this. Okay? Now, for this value, when are we to use this value? This value can be used when our volume is in cm cube. Our pressure will be in Pascal or Newton per meter square. Don't forget when and when you are to use these values for molar gas constant. Okay, so I will just wipe out because this is not the major thing. I'm just like, in case you have seen this video for the first time, because I've explained this in a latter part of this series in details. I'm just like trying to summarize so that for anybody watching my video for the first time. Okay, now we have number of particles. Now number of particles divided by this value is called If you've never heard of this value is a constant. and it's called what? Avogadro's constant. I defined all this. I don't want to define them in this video. I defined it in the first video I made on stoichiometry, so you can go and watch that video if you don't know these things where I explain them to the list. Okay, so now number of particles can also be what? When we mean number of particles, we mean number of atoms or number of moles or number of ions. So in your question, if you don't see, find the number of particles, you will see what? Find the number of atoms. If you don't see find the number of atoms, you will see find the number of molecules or find the number of ions. Do you understand? So now you can simply what? If you get that value, you divide it by Avogadro's constant. It will give you what? Number of mole. Do we understand? Now as we are solving, we'll be seeing how these formulas are applied. Now the final formula is very rare. You hardly see questions on it, but though in this video we are going to tackle the question on this particular formula. This is what? This is Q, stands for quantity of charge. Now this is F. This F stands for Faraday's constant or molar charge of electron. Faraday constant also become molar charge of electron. As I said before, all constants has value, and the value for what? Molar charge of an electron is what? 96,500 what? Coulomb per mole. Take note of these values and write. Hope you are writing down. As I said earlier, get your writing materials. Okay, so now as we start solving, see what we're going to do. It's going to be a teamwork. This is the first question we are going to tackle. If I solve this question, after that I'm going to bring another question which you are going to solve, and immediately you solve it, don't forget, drop your answer on the comment section, and after you drop it, I will reply your comments. Okay, so now that's how we're going to roll. So now let's go. Now the first question says, well, how many moles of propane are there in 0.004 kilograms of the compound? Now the first thing I want you to note is what? Kilogram. In chemistry, we don't accept kilogram. We accept for grams, especially in stoichiometry. So we have to convert to grams. Okay, that's one thing we have to do first. Now, another thing you have to see is what? How many number of moles? We are looking for number of moles. Now, the next thing you are going to observe is what? Propane. They're giving us mass. We have the compound. Obviously, from the compound name, we can get the molar mass. So this is the first question. This is the first formula. It has to do with the first formula. So now, what do we first do? Now, we don't know the compound. But I feel that, to me, I feel we should what? Convert to grams first. Now, as I said in the latter part of this series, the first, I think that's the, okay, sorry, that's the third video. Now, that third video, I taught how to do all conversion. So just follow up, okay? Now, how many kilograms or how many grams will give us kilograms? It's very, very simple. 1,000 what? Grams is equals to what? 1 kilogram. On that note, they give us 0. Now, pay attention. Kilogram to kilogram. Put the kilogram under the kilogram. This is the scale, right? So we say what? 0.004 kilograms. We give us what? X grams. So we are looking for this. This is the value we are looking for. You will simply do what? Cross multiply it. My students, you remember I taught you how to cross multiply with asterisk. Okay, for those who are just seeing this for the first time, let me simplify it even more. Now you just have to cross multiply. On that note, x grams times what? 1 kg is equals to what? 1,000 multiplied by 0.004 kilogram. Don't forget. Okay, now we will divide both sides by the coefficient of x, right? Now, coefficient of x gram is what? 1 grams. 1 kg, sorry. 1 kg. So now we can simply what? Cancel out, right? Then now, 1 kg, first of all, what do we do? Kg cancel kg. Now, 1 divided by this value is good at the same value, right? So now, under root, our what? S gram will be equals to what? Let's multiply. 1,000 There's no need to point your calculator. 1000 times 0.004 will give us what? 4 what? Grams. Now we've successfully gotten our value for conversion. Now the next thing we have to do, we will simply do what? Now forgive me, I will just have to clean this place. Let me make it smaller so that I can write on the other side of the board. Okay, now the next thing we have to do is to what? Identify the compound. Propane, right? Propane is an alkene in family, an alkene. So on that note, what do? We will what? Since it's the third member of the family, it's obviously what? C3. Prop is 3, right? Prop C3 what? H8. If you check that formula, it will go with this. Okay, now let's just make it easier. Or what? Let's just say or. Now let me draw the formula for us. Quick. Let's go. Okay. Alright, are we good? Hope we know how to draw structures. It obeys tetrahedral law. The carbons are tetrahedrally linked to each other. So now, if you look at this, okay, so now this is what? 1, 2, 3, 4, 5, 6, 7, 8. Now, this is the formula. Since we've gotten the formula, what else are we to calculate? We can easily calculate your molar mass if we've gotten the formula, right? Because we have the value for each element. Okay, on that note, molar mass is equal to what? Molar mass is equal to what? Carbon is what? We have 3 carbons, so we can easily say what? 12 multiplied by 3 plus what? Hydrogen. Hydrogen is 1. We can just say 1 times 8. Therefore, our molar mass is equal to what? Now, 12 multiplied by 3 plus 1 times 8 will give us what? 44. Now, it's not just 44. Molar mass is measured in what? Gram per mole, right? So we can just write our gram per mole. Now we've gotten our molar mass. We should be happy. We're almost done with this. Okay, so now the next thing we just have to do is to calculate the main thing we are looking for. How many moles? So we just have to impute our formula. Number of moles is equal to what? Mass. We've gotten our mass. It's already in grams. We converted 4 grams over what? Molar mass is what? 44. Are we good? So number of moles, therefore, our number of moles is equal to what? Sorry? Always remember to put your distance. Okay. So now, if we divide through, we can easily what? Cancel the grams. Grams cancel grams, right? 44 divided by 4 will give us what? It will give us 0.091 moles, number of moles. Okay, all right, now this is the value for this question. This is the answer for this question. Now I'm just going to give you your own practice question to solve. All right, so let me wipe this out. Okay, all right, welcome back, guys. Now this is the question you are to solve. Now after solving this question, simply drop the correct answer in the comment section after you finish solving. Okay, now let's go over to the next formula, which is alright, welcome back, guys. Now look at this question. This question says what? Calculate the number of moles present in what? 0.2 dm cubed. Obviously, we identify this as what? Volume in dm cubed. Okay, now what is this? Of 0.2 mole per dm cubed. Now what's this? Immediately you see mole per dm cubed, we can identify and already know that this is what? Molar concentration or what? Molarity. Okay, of what? Hydrochloric acid. Now, obviously, we know the formula to use by now. We've seen what? Volume and what? Concentration, which means we have to use this formula. And now, thankfully, our volume is in what? dm cubed. We don't have to over it by 1000. Okay, so now, what do we simply do? We say what? The answer to this question says that number of what? Number of moles is equal to what? Volume. Our volume, we put our value was 0.2 or dm cube. Multiply by what? Our what? Concentration. Forgive me for writing the volume first instead of concentration before the volume. It's the same thing. We're still going to get the same answer. Okay, so you can write your own here, you can write it in. It's all the same thing. 0.2 what? Moles per dm cube over what? 1. So now, on this note, we can simply point our calculator to get our answer. 0.2 times 0.2 is definitely going to give us what? 0.4, right? Yeah. 0.2 times 0.2 equal to what? 0.04. Yes. Okay. So under therefore, our number of moles is what? Number of moles is equal to what? 0.04 moles. Okay. Now this is our answer. It's very, very simple. If you know what to do, take note. Don't ever forget. Anytime your volume is in cm3, you will divide by 1000. Don't forget. Okay. So now I'm just going to give your own practice question, in which you are also going to drop the answer on the comment section. Alright guys, now welcome back. As you see this question, it says what? How many moles of HCl solution present in 500 cm3 or 0.2 mole per dm cube? Now this is your question under the same formula. But now you notice the difference between mine and yours. You will have to do what? Convert this to what? dm cube to use the same formula. Or if you don't want to do that, you can simply apply the formula that says what? Concentration multiplied by volume in what? Cm cube, like as given in the equation, divided by 1000. Okay, I've simplified it already. You just have to apply the formula and drop the answer for me in the comment section. Okay, now simply let's move over to the next formula. Alright, welcome back guys. Now, looking at question on this formula, we can simply see this question. What is the number of moles of 5.6 dm cube of NO2 gas at STP? Okay, now simply we can apply this formula. Why? Because we have our volume. Now, anytime you see STP, be aware of this thing. STP, standard temperature and pressure. We automatically know that we are going to be needing our molar mass. Take note, our what? Molar mass and our our molar volume. And anytime you see what? Molar volume, you know you are needing molar volume. You know the constant. It's a constant. It has a value, and the value is what? 22.4 what? dm cube. 22.4 dm cube. Okay. Sometimes you can see it like this in equation. Sometimes you might not see it. Okay, but if you don't see it, as far as you see STP, you know that's what we're talking about. So we can simply say what? Number of moles is equals to what? Number of moles is equals to what? Volume, which is what? 5.6 dm cube all over what? Our molar volume, 22.4 dm cube. Now, do you remember when I said that when your volume in the equation is given to you in cm cube, please use what? This same molar volume, but let the value be in cm cube. Don't ever forget. Okay, so now we can simply punch our calculator. 5.6 dm cube divided by what? 22.4 what? Dm cube, and it's going to give us what? 0.25 moles. Okay, so our answer, therefore, our answer, number of moles, is what? Our number of moles has a value of 0.25 moles. Okay, now this is our answer, simply like this. So now I'm just going to give you your own practice question, so that anytime you see a question like this, you will know what to do. Now, this is your own practice question. It says what is the number of moles of what? 700 cm cube of CO, which is carbon monoxide, at what? STP. I believe we know what to do. We can simply use our molar volume, which is what? 22,000 400 what cm cube. This will be the value for our what molar volume. Okay, so now let's move on to what the next formula, which is this. Alright, welcome back, guys. Now we have another question here with us. It says to calculate the number of moles. We obviously know we are looking for what? Number of moles. But now there are a lot of formulas we are going to give us number of moles of an ideal gas. This is a clue. An ideal gas. Obviously we know that it has to do with what? It has to do with what? Molar gas constant or ideal gas constant. Present in what 610 was cm cube. This is what we identify this as what? Volume. Exerting the pressure of what 710 millimeter mercury. We identify this millimeter mercury is what is used to measure what pressure at 30 degrees Celsius. Okay, now with all this formula applying, what do we do with these values? Now, the first thing you have to do is that you note we have to convert this guy first to what? Kelvin, right? So the formula says degrees Celsius plus what 273 is equals to what? Kelvin. On that note, we say what 30 degrees Celsius plus what 273 is equals to what? How many Kelvin? Just punch your calculator. 30 plus what 273 is giving us what 303 what Kelvin, 303 Kelvin. Now, after converting on Kelvin, that's not all. We have to check something. Now, our what? Our pressure is in what? Millimeter mercury. Our volume is in what? Is in what? 610 cm cube. Now, what do we do with this thing we have observed? Which molar gas constant are we going to use? Now, see what we then do. Since we have cm cube already, which means we are going to use what? We are going to use what? This. We are going to use arrow as this. Right? On that note, we have to convert this guy to Pascal. If we are to convert this guy to Pascal to get our correct answer, what do we then do? Now, we just follow our simple method. Bring out the scale. How many millimeter mercury is going to give us Pascal? It says that what? 760 what? Millimeter mercury is equals to how many Pascal? 101,325 what? Pascal or what? Newton per what? Meter square. Now on this note, what do we then do? We just have to bring our quotient down. We are converting millimeter mercury will be under millimeter. So 710 millimeter mercury. Millimeter what? Mercury will give us what? X what? Pascal. Now our x Pascal, therefore our x Pascal is equal to what? Now we just have to, there's no space, I'm going to solve other stuff there, so I'm just going to punch it straight in the calculator. Okay, so we just say 760. We say what? 710, sorry. This. Remember it's cross multiplication, right? So this times this. 710 multiplied by what? 101,325. It will give us a very huge amount. Hope you are punching your calculator also. Now we just divide this amount by what? This guy here. 760 millimeter mercury. Now the value for our Pascal is what? 94658 point what? Approximately 0.9 Pascal. Now after getting this value, we can easily apply our formula which says what? Number of moles is equals to what? Pressure volume divided by what? Molar gas constant and temperature. So number of mole therefore is equals to what? Our pressure is 9 in what? Pascal. So we just have to write it 94658 94658.9. 94658.9. Okay, multiply by what? Our volume. Our volume is what? 6 cm cube. 610 was cm cube over what? Okay, divided by what? Molar gas constant. Now by using this guy, sorry, oh Jesus Christ, 8.314, right? So this is the value we are using. Okay, so our molar gas constant will be 8.314 multiplied by what? Our temperature. Where's the value for our temperature? We've converted it to Kelvin, 303 Kelvin. So now let's calculate. Okay, now see what I'm going to do it. I'm going to punch this one first. Let's punch it down one first. 8.314 multiplied by what? 303 will give us what? Forgive me, where should I write this guy? Okay, let's write him here. Okay, 142. So after punching the up one, we just divide by this value and we'll get our answer. So now 94659.9, right? 94658.9 multiplied by what? 610 is equals to what? Now this huge value we just have to divide by this value here. 519.142. Now there we go. Now our answer is what? Our number of moles is what? 22921.27 moles. Alright, now this is our answer for our number of moles. Okay, now this is how you solve the equation concerning ideal gas. You will use this formula. Okay, now I'm going to give you one question in which you are going to solve and drop the answer on the what? Comment section. Okay, welcome back guys. Now this is your own practice question on what this formula. It says what's the number of moles? We are looking for number of moles of an ideal gas. Then you may know the formula we have to use. Present in 500 cm cube, exerting a pressure of 710 millimeter mercury at room temperature. Now, when you know room temperature, the value for room temperature in degrees Celsius, you know what to do. I don't have to tell you everything. Okay, so now I'll wipe this out. Let's move on to the next stuff. From the question, we can see calculate the number of moles present in 2.02 times 10 raised to the power 23 atoms. Now, from these atoms, you already know the formula to use. We know that we have to use this formula. I told you before that number of particles can also signify number of atoms, number of molecules, and number of ions. So on that note, we can simply say what? Number of moles, N is equals to what? They've given us a number of atoms, so we can just write it 2.02 times 10 raised to the power 23 over what? 6.02 times 10 raised to the power 23. Now on this note, your JAMB calculator might not have the features in which this guy has. So now you have to be smart. You have to calculate this thing on your own bit by bit. On that note, we can just say what? Number of moles equals to what? Now first calculate this part before you calculate this part. Okay, so now we can simply say what? Now punch your calculator. 2.002 divided by 6.02. So now our answer will be what? Okay, we have a very huge value, 0.335548178. Now this value, what do we do with this value? We've gotten, but we've not calculated this guy. How do we calculate this guy? Now it's very simple. Since the base of these guys are the same, we just bring down the base. When we bring down the base, this thing, now if it's division, what do? You subtract the powers. But if it is multiplication, you add the powers. Now on that note, what do? We will just write 23 minus 23. Since technically we are going to have 0. Okay? Now, 10 raised to power 0, what is it going to give us? It's going to give us 1, right? So on that note, if we times 2, what are we going to get? We are obviously going to get what? Number of moles is equal to 0.335. Okay, we can stop here as our what? Number of moles. Now, this is your answer. You are going to see something like this. Now, you might not see this in the option if they want to be wicked. They might want to like convert to standard form. But now, if they convert to standard form, I trust you know what to do. You just have to look at the option and compare it. You count it, then you know that's our standard form. So we're not focusing on standard form in this video. So okay. So now I'm going to give you your own practice question in which you know what. Now, this is your what? Practice question in which you are going to use to test your ability on how much you know solving of stoichiometry. Now let's move on to what the next aspect, which is going to be the last for this particular section. If you see this question, it might not seem like it's stoichiometry question, but now that is how you need to pay attention and be careful. Now, when you see what is the charge, first of all, you know it has to do with quantity of charge carried by what? 0.5 moles. Now, from this, you know it has to do with stoichiometry. Anything, no, I told you guys, the basis of what stoichiometry is what? Number of moles. Now, when you see an electron, this is suspicious. Then you confirm that it has to do with what? Molar charge of an electron, which is F, also known as Faraday's constant. And now they give you the finest expo, the biggest expo here, 96,500 coulomb per mole. When you see this value, you know we are going to use the formula that says what? Number of moles is equals to what? Quantity of charge over what? Faraday's constant. Now with this, what can we do with this? They've given us number of moles already. They've given us our constant is always there. Even if they didn't write it, you should know. Okay, so on that note, we have to do what? Change subject or formula. We will make quantity of charge as the subject of formula. How do we do that? We cross multiply. So now Q times 1 is equals to N times what? Faraday's constant. Now we can what? Divide both sides by the coefficient of Q. Now we just have to cancel out what? Q now is equals to what? N times F. Now it's quite simple. Therefore, our answer would be what? Q, which is quantity of charge, is equals to 0.5 moles times what? 96,500 what? Coulomb per mole. Alright? So now, the first thing you have to do, cancel the mole, it remains coulomb, right? Now, 0.5 multiplied by this guy, which is 96,500 coulombs. We are going to get what? Quantity of charge will now be what? 48,250 what? Coulombs. Alright, now this is our answer. 48,250 coulombs. Alright, that's the quantity of the charge. Okay, so on that note, let me give you a final practice question in which you are also going to drop the answer here at the comment section. Alright, welcome back guys. Now, this is your own practice question. Make sure to solve this and drop it here at the comment section. Now, after watching this video, I believe that what learning has to be fun and also interesting. It doesn't have to be boring. So after watching this video, your sweet drop is always there for you to entertain you. And aside from that, please, if you know you enjoyed this video, you learned how to solve stoichiometry with ease, please give us a like and don't forget, drop your answers in the comment section. Aside from that, the most important, please subscribe. That's the only way you can help this channel. Now, thank you for watching. See you guys later.
Who owns this number? Okay, because I'm calm in this relationship, you think you can be cheating on me with anything, just anybody. Who is Lucia?
How did you become this aggressive?
Who is Lucia?
Listen to me, let me explain.
Who is Lucia? Who is Lucia? Who is Lucia? I'm asking you a question. Who is Lucia? Oh God, the stupid girl keep calling you. Who is Lucia?
You know this love is just
Who is Lucia? Who is Lucia? I'm calmly asking you.
You are calm like this and
I'm calmly asking you.
You are slapping
I
me.
will smash your TV. I will smash this phone. Who is Lucia?
You smash my TV.
I will smash your TV and I will smash this phone and I will still smash your head. Who is Lucia?
You have been slapping me.
Who is Lucia? Who is Lucia? Who is Lucia? On top of this 2 years relationship, you want to start cheating.